So question 21. Charlotte the spider is walking along the web, shaped like a 5-pointed star, shown in the figure below. The web has 5 outer points and 5 inner points. And each time Charlotte reaches a point, she randomly chooses a neighboring point and moves to that point. So Charlotte starts at one of the outer points and makes 3 moves. Revisiting points is allowed, which is important. And then what is the probability that she is now at one of the outer points of the star when she finishes all her moves? So let's take this top one as a starting point. So you notice that you can only go from you can only go from in to out. So what this means is you can't walk from an outer point to another outer point. That's illegal in this situation. So if you want to reach like an outer point like this, you have to go from all of these 5 inner points. And so what that tells us here is that if she starts at this outer point as her initial point, she starts at an outer point, then she can only go to an inner point. And from an inner point, she can choose to go to an inner point or to an outer point. But because she wants to reach an outer point as the last solution, it means that in the middle, she must go to an inner point. So that tells us a few things, right? If we view this, the first move as blue line, second as a green line, and the third as a purple line. Let's start from the blue line, assuming that she wants to reach an outer point at the end. So she starts here at the top. She has 2 solutions. You can go down to the left one, the left inner point, or the right inner point. So let's say she goes to this one as her first position. For the second, she can go to either this inner point or this inner point. Let's say she goes to this inner point as her second location. And then finally, she has 2 choices of outer points. You can go to this outer point, or she can go to this outer point. And so let's say she chooses this outer point, right? So what we notice here is that each path, assuming she takes, and she has the goal of reaching an outer point, she has to take 2 paths and take 2 choices at every turn. So in total then, how many, we can write that out as a probability. 2 times 2 times 2, since she has 3 moves, and at every move she has 2 choices. So then what are the total number of choices that she has? Well, if we look at this graph, right, from the first point, she still only has 2 different places that she can walk to. So for number 1, that's still 2. But for number 2, if she goes here, she can go 1, 2, 3, or 4. So she has 4 different places that she could potentially go. So 4. And for this final third move, it is also the same logic. She has 4 different places that she can go. 1, 2, 3, and 4. Notice here that like revisiting points is allowed, which is why she could potentially go backwards like this. Okay, so then we have at the top is 8 and on the bottom is 32. That easily comes down to 1/4 as our final probability.